Hi, my talk is Measuring DevOps with Tekton. I am Dina Portman. I am a developer programs engineer at Google. My background is in data. I've worked as a data analyst, I've done data engineering, I've done data consulting, and also machine learning. And so I'm really excited to bring actionable data insights to DevOps. So let's talk about what DevOps is. If you Google it, these are some of the answers you'll get. DevOps is dead. DevOps is not a catalyst for cloud. DevOps is a culture. DevOps is not a role. DevOps is not a team. Apparently, there are a lot of things that DevOps is not, but it's a little bit harder to say what DevOps is. Lots of possible good definitions. Here's a good one. DevOps is an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. And in picture form, DevOps is a way of working in which we apply communication and automation to achieve velocity and reliability to make users happy. So why do we care? What does DevOps do? That brings us to DORA. DORA is the DevOps research and assessment team. It's a team of analysts who use academic methods to study how software is made and shipped. They focus on the effectiveness at the team level, and they use a variety of statistical methods to determine relationships. That is, what practices and capabilities are influential in driving successful teams. And what they found is that software delivery and operational performance is key. If you want to have good business outcomes, you really need to have good software delivery performance and operational performance. So that is to say, delivering software quickly, reliably, and safely is at the heart of technology transformation and organizational performance. So over their 6 years of doing research, they identified these 4 key metrics as being really the metrics to use to measure the performance of a software development team. And these metrics are actually predictive of success, which is a stronger relationship than correlation. And they are lead time to change, deployment frequency. And so these really represent our velocity. And then change, fail, and time to restore. And those are measurements of our reliability or our stability. And what we find is that people who do well in these areas, they do really, really well. They have both extremely strong, fast velocity and extremely strong reliability. And so when we look at elite performers, we see that they are deploying code 208 times more frequently than low performers. Their lead time from commit to deploy is 106 times faster. Their change failure rate is 7 times lower, and their time to recover from incidents is 2,604 times faster. So our elite performers, they're not sacrificing velocity for stability or vice versa. They're doing really well at both. And so now that we've talked a little bit about what DevOps is, I'm going to talk about the 4 key metrics, which is an open source tool to collect and automate the calculation of these 4 key metrics. So just to refresh, they are lead time to change, deployment frequency, change failure rate, and time to restore. In the research, it really focused on doing surveys, but we want to do systems data because we have it. We actually have all of the data that we need to calculate these metrics. And if you really want to have an unbiased view of your organization, especially like the trends and how the performance changes over time, then systems data is really the way to go. So that brings us to our first challenge. The challenge is that developers use many different kinds of tools and environments to do their work. So how do we capture all of it? you're doing deployments in one place, you're doing your commits and your pull requests in another place, you're filing your bugs somewhere else. So how do we capture all of this? And how do we account for the unknown data sources? I perhaps, I know about GitLab and GitHub, but maybe you're using Bitbucket. And so how do I build an open source team? How does my team build an open source tool that allows you to put your data from your sources that we don't know about into this pipeline? So the solution that we came up with was to create a generalized pipeline that takes in events via webhooks and ingests them into BigQuery. The sources that we know about, they're parsed properly because we already have the ETL workers there to pull out the data that we know about. And unknown sources can be categorized with the SQL script. So that brings us to data mapping. The raw events table is basically a DevOps log. So this is where all of that webhook data is flowing in, and it should contain every event related to development, deployment, and incident management. So when in doubt, stream your data to this table. And from the raw events table, we create these 3 derived dimensional tables: changes, deployments, and incidents. Because if we have a view of changes as an object and a view of a deployment as an object and an incident, then we can calculate the 4 key metrics. This is all we need. So let's talk about the metrics. Our first metric is deployment frequency, which is defined as how often an organization successfully releases to production. And this is the easiest one to calculate because it just requires the one table, deployments. So if you're using a CI/CD system, like Tekton, you have all the data that you need already. So if we stream this information to our table, we can use it to calculate frequency. And the Dora team bucketed every metric into elite, high, medium, and low performing teams. So in this case, daily deployment frequency falls into the high performing threshold, and so we represent this with a green badge. Our next metric is lead time to change, which is defined as the amount of time it takes a commit to get into production. So lead time to change requires 2 important pieces of data: when the commit happened and when the deployment happened. This means that for every deployment, we need to maintain a list of all the changes included in the deployment, which is easily done if you're using triggers that have a SHA mapping back to the commits. With the list of changes in the deploy table, we can join back to the changes table to get the timestamps and then calculate the median lead time. The dashboard puts the lead time into buckets defined by the Dora research: less than a day, less than a week, less than a month, a year, and less than a week is medium. So we are showing that with a yellow badge here. Our next metric is the change fail rate, which is defined as the percentage of deployments causing a failure in production. To measure the change fail rate, we need to know 2 things: how many deployments were attempted and how many resulted in failures in production. So our deployments are the denominator, and the incidents is the numerator. And so to get this number, we need our total count of deployments, which we can get from our deployments table, and we need to link it to incidents. Now, incidents could come from anywhere. Maybe you are automatically detecting some of them for something like Stackdriver, or maybe you have a bug system, or maybe you're using like labels on GitHub incidents, or you could have like a form with like a spreadsheet pipeline, or even a fully fledged issue management system, which would be ideal. The only requirement is that it contains the ID of the deployment, so we can join these 2 tables together. Next, we have time to restore. This is defined as how long it takes an organization to recover from a failure in production. Again, you need the deployments table and the incidents table, but this time, instead of just taking a rate, we need to get the timestamp so we know the delta of like when the incident was created and when it was resolved. And the incident will have been created, when the deployment happened that contained the failure, and then the resolution is the deployment that fixes it. Similar to the last metric, the data could come from any incident management system you use. So to refresh, this is our 4 keys design. We have our events, which are happening, where they're happening. So, like GitHub, GitLab, Tekton, whatever it is that you're using where you're doing your DevOps work, then our event handler, which is the webhook that just accepts this data. And then it goes to PubSub, which goes to the data parsers. And they do some light ETL, and then it goes into the BigQuery events raw table. And from there, it's pulled out into the dimensional tables of changes, deployments, and incidents, and that goes into the dashboard. So how does Tekton fit in? Well, we want the events from Tekton going into the event handler, to the PubSub, to the data parsers, to the raw events table, ultimately to deployments, because if we're using Tekton for CI/CD, this is where we're going to get our deployments data. And I have a video showing the setup of the 4Keys project. And we're going to walk through it, and I'm going to show you how Tekton fits in. Okay, so we're going to run the setup script, and the first thing it does is ask us if we want to create a new Google Cloud project. I say yes. And this is going to house all the infrastructure for the 4Keys pipeline dashboard. It's going to ask us what kind of version control system and CI/CD system we're using, putting in GitHub and Tekton, and then it starts turning on all of the APIs. It starts building and deploying the Cloud Run workers. It creates the PubSub topics and subscriptions. It creates the service accounts and sets the permissions. And it also creates the BigQuery tables. And then asks me if I want to create a separate new project to test deployments. I'm saying no. I do want to generate mock data, so I say yes. And then it's creating mock data, schedules the BigQuery tables, and now it's going to, once this is complete, it's going to have a pop-up, and we're going to have the opportunity to connect to a Data Studio dashboard. So this will allow us to pull all of the data from our project into a template that we've made for 4Keys. So gotta authorize it. And then there's gonna be a drop down. So you choose which project you wanna use. And then connect, and then create reports. And then you have the option to not use the template, but the template's already set up. So it pops up and it looks like this. And so you can see that we look like we're a pretty decently performing team. We got some green badges, some yellow badges. We have a couple places where we could improve, but all in all, this is pretty good, pretty good standing. So let's look at the underlying data. 4Keys events raw. And we can see that there's a lot of data in here. It all says GitHub mock. So this is our mock data. Let's exclude it. And then when we run this query, we will see that there's no data. So we want to integrate with the repo so we can get some data, real data. And so first thing we need to do is we need to get the URL for the event handler. And then the second thing we need to do is we need to get the secret. That's we're storing it in Secret Manager, so we can check against it when GitHub sends us these events. And we want everything. We want all the events, all the data that happens. There we go. Add webhook, and there it is. So let's go ahead and test this out. I have this forked project from Kubernetes engine samples, and so I'm just adding something to the README here. I'm going to create a new branch, and I'm going to do a pull request. 4Keys data pipeline. That's what we're doing here. Okay, so when I look back at the data in BigQuery, see, hey, look, there's a pull request and a push event. So it's working. It's running all the way through. Our data is in our tables. Excellent. So next, we need to integrate with the Tekton pipeline. So first, let me show you what I have set up here. I have it so that when the event is a push and it is to my master branch, then it will trigger this pipeline, and I am passing down this git revision parameter so that I have the SHA there. Okay, so let me show you that it does work. And so if I just commit here, and I'm just pushing directly to master so that I can trigger this. When I refresh my application, my Hello World application here, then it says, hello, Tekton trigger. So great, it's working, it's triggering, it's passing all the way through, excellent. So now we want to get the data from this kind of event into our 4 keys pipeline. And what I'm going to do here is I'm going to use the default cloud event sync. So this sends all the cloud events that are happening in your Tekton pipeline to the URL of your choosing. And so I'm just going to put an event handler. This is a public URL though, so I do want to like add some kind of like token or secret or something. So I'm just going to put this in kind of like an API key right here, so that my event handler can confirm that this is an authorized source. So I'm applying the config there, and now that's updated. So when I update this again, and now instead of hello Tekton trigger, I'm going to do hello 4 keys. Then when I refresh, oh, yeah, when I look at the data, I can see all of these Tekton events. I can see all of the task runs and the pipeline runs in their different states, which is really exciting. And ultimately, what we're going to look for is where pipeline run is successful, and that is going to represent a successful deployment. And let's go ahead and look at our app, and there it is. It says hello 4 keys. So that is how you set up the 4 keys pipeline with GitHub and Tekton. So there's a few little challenges when it comes to Tekton. Actually, it's just kind of one big challenge. It's just that the data payload is a product of your pipeline configuration. So it's a little difficult to create an open source kind of query that's always going to work for people. It's different when you're working with, like the GitHub data or like even the cloud build data, because those data models, they're kind of set, and you know like this is a push event. It says it right there, and so I know that is that kind of change. With Tekton, your pipeline run doesn't actually have to deploy anything. You could just be, echo hello world could be the output of what happens there. And so I had to just kind of bake in some assumptions into the SQL queries and into the infrastructure. And so the first assumption that I had was that the event handler will be receiving cloud events for Tekton. If you have some other kind of sidecar and you want to send data in a slightly different form, right now the 4 keys project is only set up to recognize the cloud events from Tekton. The second assumption is that the pipeline contains a parameter called git revision with the GitHub or GitLab change that triggered the pipeline. So this is the commit SHA. It is specifically looking for the name git revision. So if you called it something else, it wouldn't find it. And lastly, the biggest assumption perhaps is that a successful pipeline run is a successful deployment. But if your definition of these things is different, you can edit in the SQL, and that is fine. That's why it's set up that way. And so here's the dashboard. This is the end game here. In the middle, we have the badges that are the 4 keys from the DORA research, and this is backed up by 6 years of research. And then around the corner are the systems data over time. And so this is nice because it gives you like an early warning system of like whether your performance is improving or maybe it's dropping a little bit. And so you'll be able to see it in these charts in the corners here before the buckets flip over, because the badges in the middle are looking at the past 90 days. So the other ones are kind of like early warning systems. And you can go ahead, check it out, try it out at github.com, Google Cloud Platform /4 keys, and really would welcome any feedback or contributions. And thank you for coming. I am here to do Q&A if anybody has questions other than where the slides are. I would say there are other ways to do reporting with Tekton, usually involving sidecars. I went with the sync because it seemed like the simplest thing that you could possibly do to integrate with the system. Future enhancements. That's a good question. As far as feature enhancements go, definitely I'm looking to integrate with more and more systems. Also thinking about ways to create the data a little more abstractly, possibly create like an API, which would help with the integrations. Right now, everything is, it's relational databases. And the benefit there is that if you have an analyst on your team, or if you know SQL, it's pretty straightforward to go in and extract the information that you need and to say like, okay, well, for our team, for our organization, a successful deployment is when the Tekton pipeline says successful, and then when I look at the config and it had, I don't know, this task run associated with it or something like that. And so like you can just extract that from the JSON, because the entire body of the event is sent to the table and in its JSON format. And BigQuery, and I think most SQL systems now support JSON parsing. And so you can use just like a where filter and say like, okay, on the deployment script, you can say where this equals this equals this. And so it's simple that way. Do you only use Tekton pipelines for CI/CD? I work on a team that focuses on CI/CD, so that is naturally my focus. I haven't used Tekton pipelines for anything else. But other types, okay, the question is there any plan to leverage other types of data sources like in FloodDB? The question says, we currently store similar metrics from our Jenkins and Spinnaker pipelines in Influx, and we want to move the data to GCP eventually. I don't see why not. If you go to the 4Keys pipeline, if you want to just file an issue with that request, I want to support as many things as possible that people are using. So yeah, if you wanted to file an issue asking for that feature request, that was a great idea. Or you could you can build out the integration and send us pull requests. Also a great idea because it's open source. I think I mentioned that a few times. Oh yeah, so I see. The question was, do you only use Tekton pipelines? Whoops. Do you only use Tekton pipelines for CI/CD? No, it supports Cloud Build as well, and also GitLab CI/CD, and also GitHub CI/CD. There was some kind of GitHub deployment pipeline thing that I also built in support for, though I haven't actually used it in practice. And I seem to have clicked on some things and lost the chat. Oh, there it is. Oh, InfluxDB. Okay, thank you. Bring your own stack, like a plugin model. I'm not entirely certain what you're getting at there. Are you saying that because in the version that the project that we're presenting, the stack is on Google Cloud and Cloud Run, et cetera, you would like to take the same compute containers essentially and just deploy them on different things? That's kind of what I'm interpreting that as. And if that's the case, I would say you can absolutely do that. If you look at the project, there's very little. I mean, the BigQuery part, it uses Google APIs. But in terms of the actual compute, it's using Docker files, it's using containers. So if you wanted to build those and deploy them onto another system, there's nothing stopping you from doing that. obviously I work for Google, so I think Google Cloud is really great and the way to go. But it's an open source project. You can fork it. You can make it your very own, and I encourage you to do that. Yeah. And so when I say that it supports Tekton and Cloud Build and GitLab and things like that, what I mean is there's a data mapping challenge. Each of these sources present the information about the events differently, and it's a different JSON object. And so to extract the pieces of information that are important and significant for the 4 keys, you have to know the structure of each of these objects. And so when I say that it supports these kinds of CI/CD systems or version control systems, it just means that those are integrations that I or people on our team have already built out. So I think it would be great if we had it for Bitbucket, Jenkins, Spinnaker, all the things. I am hoping that we can support, have it pre-built, ready to go for as many of the popular products as possible that people use. It's really just a question of taking the time to do the data mapping, and then once the data mapping is done, once it goes into the system, into the table, and it says this was a push event from this source, and here's the payload, then the next step is kind of looking at that data. And when you do this kind of data analysis, you have to look at the data, and then you have to compare it to the real world. This says this thing and it did this thing. What actually happened in my system? And then once you can align those things, then you can look for the parameters that are actually reflective of the thing that you're trying to achieve. In this case, a change, a deployment, and an incident. Okay, and Rakesh saying JSON format can be standardized as a separate open source project. Yeah, absolutely. I think, are you saying we could have basically a big map and maintain it, or we would we would encourage people to use the same format for across all the products in the world? I think data standards are wonderful and important. I think that is, if we as an industry could agree on that and have a schema in schema.org or something like that everybody would use, that would be amazing. But things like that usually take time to catch on unless there's a really strong incentive. So it's usually if we want to go down that road, we should also do the thing that we're doing right now of kind of building them out, basically meeting people where they are. It's hard to incentivize people to do things with the promise of rewards that come down far down the line. Things like recipes or jobs in Google search, when we had the schema for those, people really picked those up because it affected how it was represented in search. So that was an immediate reward that they could get, and they could show up in more search results. Something like this, which is a little more niche, and the benefits are not as immediate. What do you get if everybody updates their their data models to use the same standard, then we are better able to measure our performance metrics and compare ourselves over time, and also compare ourselves to each other, and therefore improve. But that is a long process, improvement measuring. So it's just not as an immediate incentive. But we are thinking about it. We are thinking about it. And it starts obviously at home in your own teams. So starting with like deployments, what does a deployment mean, and what pieces of data do we need to have represented in it? Obviously, you need the ID, you need the list of the changes that were included in it, and then you should have things also like traffic and where you're deploying it to, the status. We're doing a lot of deep thinking of like what a standard schema could be, but I think that is a long-term process and a long-term goal. Short-term, obviously, the easier, quicker thing to do. I say easier, quicker is the tools that you use. You can look at their JSON and say, oh, so here they call this event.id, and that's the thing that I need to be my deployment ID. That's the kind of advanced mapping that we need to do. Thank you for the very stimulating conversation. It's kind of fun coming in through chat, and then I'm responding with my voice. And thank you all for coming. I'm a big data nerd, so this is really fun. Bonjour. Okay, I've completely lost track of the time. I'm not really sure when I was supposed to be on for 10 minutes of Q&A, so probably coming up towards the end of that. Actually, probably over that. I don't know. Okay, cool. I guess I'll say that's the end of the Q&A. If you have more questions, you can go to the repo. I'm on the Twitters at Dina Portman, I think. Awesome. Thank you guys for coming.